Hi everyone, I'm David Wismer, a recent graduate of the Metis Data Science Bootcamp, and what I'd like to do today is walk through my PowerPoint presentation for the final project from the bootcamp. This was completed during the Unsupervised Learning and Natural Language Processing module of the bootcamp, and my project is a web application called TokenSense. So the goal of my project was to create a web application that tracks the pulse of the Bitcoin market with two primary functions. The first is clustering historical dates by their sentiment and activity metrics, and the second is topic modeling, looking at the prevalence and the sentiment of text-based topics across time. So I'll first start out by describing my data pipeline. I built 4 separate web scrapers to scrape news articles from 4 different websites. I scraped 60,000 articles, of which only 19,000 were used in the actual modeling. The reason for that is that data was sparse prior to 2017. I used Selenium and Beautiful Soup in those web scrapers. I also used PyTrends to get Google Trends information and PRA library to get both Reddit text from the comments and also metadata related to the Bitcoin subreddit. For cleaning and modeling, I used Pandas and NumPy to clean my data, TextBlob to do all of my sentiment analysis of text. I used GenSim for topic modeling, and scikit-learn for all of my clustering algorithms. In production, I used Tableau Public to create a variety of dashboards, which I organized onto a Streamlit app that I'm calling TokenSense. So now I'll go through my feature engineering for the sentiment side of my project. First, we have Reddit comments. For these, I put them through TextBlob to calculate polarity and subjectivity. Polarity is the positive or negative nature of a text, whereas subjectivity is how opinionated that text is. I did the same thing for news articles. For Google Trends, I calculated the activity for a given date versus its prior all-time median. This was in order to help fix some hyperbolic issues in the data. For trading info, this is price information. I used the metric versus its prior all-time high. And for on-chain metrics, things collected through glassnode.com, I didn't really need to alter these. These were net unrealized profit and loss and net transfer volume. So here we get a look at principal component analysis for my sentiment clusters. And what we see is that with 8 components, I was able to explain around 95% of the variance. So I did reduce my components by a few. And now we'll get a look at a 3-component PCA for a couple of our clustering methodologies. The first is k-means, the second is Gaussian mixture. And the main thing you'll notice between these two methodologies is that Gaussian mixture is able to find more oblong shapes or more oblong clusters within the data. So rather than finding simply spherical clusters, it'll actually find things that are maybe like slowly changing over time, which is good for me because I'm doing a time-based, time series data problem here. And so when things slowly change across time like that, these oblong features can be helpful. And you'll see that on the Tableau dashboards as well. So let's get into it. I'll show a quick demo of when everything's going right, the blue cluster, versus when everything's kind of going wrong, the purple cluster. So on the dashboards here, you'll see a variety of different metrics, and along the bottom you see the dates and color coding for each of our different clusters. Here we're showing price versus all-time high, for instance. On the right, you see a box plot distribution for each of our clusters for the given metric. And now let's flip over to k-means methodology. If we focus in on just the blue and the purple clusters, we'll see that the purple cluster tends to come when price is low relative to all-time high. Blue comes when it's high versus all-time high. That's also reflected in the box plots. And now looking at activity, we see that blue is associated with high levels of activity versus purple with lower levels of activity. Also true for Google activity, Reddit activity. And now let's take a look at sentiment. For Reddit polarity and subjectivity, we don't see much delineation between the different clusters, but for news polarity and subjectivity, we see that the purple cluster is lowest, both in terms of polarity and subjectivity. Now let's get into the topic modeling. So I'll start with going through the workflow. First was pre-processing of data, things like using regular expressions, tokenization, stop words, lemmatization, and term reduction. This was all done with the GenSim library. Next, I did my topic modeling. I used an LDA model, or latent Dirichlet allocation. I then obviously had to optimize my parameters. I decided to maximize what's called a coherence score, which is something within the GenSim library. Then I looked at my top articles and made sure they made sense and came up with topic labels. And fortunately, the topics were very cohesive, so I could label them quite nicely, as you'll see on the Tableau dashboards. And then from there, I did topic analysis. So I calculated the article polarity and subjectivity, as well as the dominant topic share within each of my articles. And in doing so, I was able to calculate daily prevalence and sentiment of topics across time. So I can have really nice time series information on topic prevalence and sentiment. So here's a quick look at the prevalence of topics across time. And you can see how they are changing, but maybe this stacked area chart isn't as useful as perhaps just a line chart. Let's focus in on just one topic for simplicity's sake. Institutional investing became very popular in Q1 of 2021. It kind of rose in popularity throughout that time. You might remember some large institutions investing in Bitcoin during this time. It was a very hot topic. Now we'll look at sentiment. This is showing article subjectivity across the bottom versus article polarity on the y-axis. In the bottom left, you'll see more negative sounding topics, things like lawsuits, crime, government regulation. In the upper right, you see more positive things like blockchain innovation, education, security, etc. And now let's do a quick demo of the topic modeling portion of TokenSense. We'll look at institutional investing specifically. So here you see we're looking at institutional investing. Topic polarity and subjectivity over time is the first thing you see here. It's kind of coming down slightly over the past couple of quarters. Here we see it peaked in prevalence in 2021 Q1. Here we're seeing some top articles, things like Morgan Stanley, Tesla, MicroStrategy are showing up, Grayscale. You can sort these by a variety of different metrics as well. Now let's look at the LDA visualization. So what we see here, again, we can focus in on our topic, topic 14. Here we're seeing the top terms related to that topic, things like investment, institutional, obviously. And if we adjust our lambda, we can even see some of those big entities like Grayscale, MicroStrategy, JP Morgan, Fidelity, etc. So what's next for TokenSense? One, I'd like to flesh out the data pipeline to allow for more periodic updates. Right now, topic modeling is a very intensive process, so it does require a human touch, which I don't know if ever can really be eliminated. I'd also like to perform topic modeling on Reddit data for comparison against news articles. And then I'd like to implement additional clustering and NLP techniques. I'd like to explore dynamic time warping since all of my information is time series data. And then I'd also look into named entity recognition. So thanks for your time today. If you have any questions, feel free to post them in the comments or reach out to me. And you can also take a look at my Medium blog post and a walkthrough video that I've done on my code review and a more in-depth demo of the TokenSense application. Thank you.